Alright, so today we're talking about area. Area is the amount of surface that a shape or a region covers. Last time, with perimeter, we were talking about going around a shape. Today we're talking about how much, or how many I should say, squares it would take to cover up that shape of a given unit. In this case, Japanese blocks. Well, why do we have to even calculate area? Practical examples might be something like a floor tile. If you were covering your house with a tile, you'd want to know how much tile you'd need to cover the entire floor. So you'd have to figure out how many square units or thereabouts to buy. A square unit basically means that it's got the same length on each side. So when you go to calculate, if you measure 1 unit, you can find out how many blocks of that unit it would take to cover the entire surface. But that's a lot of blocks. And there's a more efficient way of doing that, and I'm going to look in a second about that. Not everybody uses the Japanese block as a standard unit, so what we do is we use the metric standard units. We have square millimeters, which means 1 millimeter length by 1 millimeter width. Okay. Square centimeter, again, 1 centimeter length by 1 centimeter width. A square meter, which would be 1 meter length by 1 meter width. And a kilometer, which would be 1 meter length by 1 meter width. That's pretty big. That's when we're talking about something like how big a forest would cover, or maybe a schoolyard. The formula for the area of a rectangle is simply A equals L times W, or area equals the length of the rectangle times the width of the rectangle. And to be honest, it's not really super necessary to say which one is the length and width. Generally, the length is the one that's going to be longer, and the width will be the shorter one, but, it really doesn't matter. So if you mix that up, that's okay, as long as you know that you're going to be timesing one value by the other value. Here's some examples. So let's say, for example, you had a rectangle that had a length of 4 centimeters and a width of 3 centimeters. You'll notice that I marked congruence marks on that rectangle, but you know by now the rectangle has 2 pairs of equal length sides. You could take your time and cover these with blocks to test that and say, okay, 4 by 3, and count the number of blocks there. Or you could simply use the formula and say A equals length times width equals 4 centimeters times 3 centimeters. So the area for that rectangle would be 12 centimeters. In another example, we have a rectangle that's 4 centimeters by 5 centimeters. Again, you could actually manually do it, and you could count up all the centimeter blocks, but it would take a long time. So instead, you can say the area equals length times width, 5 centimeters times 4 centimeters, and your area would be 20 centimeters squared. Remember, that's a centimeter by a centimeter. It's a square centimeter. So not like the length where you're just having one side, you're going square by square. That's why your unit will say square centimeters. Once in a while, there's a trickier question where you will have the area, but you'll be missing the other components. And what you need to do is remember that if area equals length times width, then width would equal area divided by length. So you could say 15 divided by 3, and then get the missing dimension, which would be 5 centimeters. If you're not sure if you got it right, you could go back and multiply and say 5 times 3, and that in fact gives you 15. One more example of that would be 24 centimeters is the area, but this time we have no length. Oh no! What do? We remember area equals length times width, so we can go backwards and say then length equals area divided by width, which would be 24 square centimeters divided by 4 centimeters, equaling 6 centimeters. Again, multiplying to check, 6 times 4 is 24. And that is area.